So up here I've chosen an a molecule, sorry. A great molecule is a great example here. So this is ozone. This is what all those people...
Mr. Wall.
Yes?
I've got Amy in the office. Is that okay?
Yeah, that's fine.
Thank you.
So on this, the ozone, it's what everybody's all concerned about, the ozone layer. So in this, we're going to use this to go through all these steps and to introduce a new topic and concept. So first rule, we must find the center atom. It must be the lowest electronegativity of them, except for hydrogen. Hydrogen will never be the center, so what is the center?
I guessed.
It's a pretty good guess. I normally look and say you had a 100% chance of getting it right, but I gotta go with 99 because
That was like
whenever I'm grading the element quiz and I see somebody be a volume, I'm like, man, why couldn't you be a basketball player? I'd have so much fun with that.
Who did it though?
I ain't telling you.
Oh, let's
Do you know what we're gonna learn ours yet?
I have not. I'm finalizing. I have finished them. Step 2, draw the skeleton of it. So the skeleton just has the other atoms bonded to it. Give all atoms a full octet when required. What we're talking about when we're saying when this is required, we're literally speaking of when this situation, when they don't break the octet rule. Every one of them want 8, except when they break the octet rule. So in this case, let me get the periodic table up here. How many valence electrons does oxygen have? That's what we're all concerned with in these 3 oxygens and how many they have. So we're going to start with this one. Okay, we're going to start with left. We'll go left to right. So this oxygen wants 8 valence electrons. Does oxygen break the octet rule? No. There's only 4 that break the octet rule.
What are they?
First is hydrogen. Hydrogen will only make 1 bond. Second is boron. Boron will only form 3 bonds. Third is phosphorus. Phosphorus will form 5 bonds, take 10 valence electrons, and it will only do this if and only if it is bonded with high electronegative elements such as oxygen, chlorine, and fluorine. They must be bonded to those 3. If it does not bond with those 3, it will not break the rule. Same thing for the 4th one, which is sulfur. Sulfur will make 6 bonds. Only if bonded with oxygen, chlorine, and fluorine. They have to be highly electronegative. So in this case, oxygen wants 8. How many does it have right now?
4.
This oxygen. 2. Because this bond here counts as 2 electrons. You have to remember that.
Holy crap!
So, 6. I need to give oxygen 6 electrons to give it a full outer shell. The bonds, they count as 2. Yeah, like every dash will count as 2.
What up here?
Like this right here is 2 electrons, and that right there is 2 electrons.
You should have drew the arrows.
What it is these bonds, Christy, is like this oxygen is sharing an electron with that oxygen. But this oxygen is also sharing an electron with this oxygen.
That's why we have the up and the down arrows. Kinda.
Yes, but nah, I'm not going to go there in this class.
This is off subject, but do you know which party Mary's coming to?
6th period.
I do not know.
She said she's coming to one of the 2, so.
I hope it's fit.
I have no idea. Y'all can message my wife and figure it out.
Total charge.
Also, did you ever figure out what food you're bringing for tomorrow?
Me?
Brownies.
For
I have no idea. I told y'all message my wife.
Well, that's one.
no, I was talking about for this
Harrison?
person. Yeah, for Harrison.
Oh, yeah, chicken enchiladas.
I'll tell him.
I told her.
Oh, yeah.
But you can tell her again. All right, so 6.
You messaged his wife.
6 electrons. So now we'll divide this out by 2 because every lone pair, okay, the lone pairs come in pairs of 2. So 6 divided by 2 is 3. I need 3 lone pairs. So there's 1 lone pair, 2nd lone pair, 3rd lone pair.
Just dot.
Build each dot.
Yeah, they're just dots.
They stand for electrons.
Electrons.
So do we divide by how many dashes there are?
No. You divide because pair. Lone pairs, okay? The key to it is pairs. Like you have a pair of shoes. If I asked you, how many pairs of shoes are you wearing right now?
So there should be 3 pairs of 2.
Yes, that's exactly it.
The middle one should have 2 pairs of them, right?
So we always.
Yes.
So we always divide by 2.
Yes. For the lone pairs here.
Okay.
Okay.
So
Hey, oh my gosh, I totally forgot, guys. I forgot to tell y'all. I have great news.
We beat second period in the periodic table.
I have. You know how much I love you guys. I have figured this out. I need to give you guys another easy quiz.
no thanks.
Yes.
I'm gonna give you guys another easy quiz. And it's literally this is what's gonna be.
Periodic table?
Because we're getting ready to go. No, but it's gonna be almost like the periodic table. I'm gonna give you a list. This list, you'll get it when you come back, okay? I'll either give it, I'll probably go on and print it and give it to you, but the quiz is gonna be when you get back.
But we're going to forget.
That's why you
I'm gonna
study
give you time once you get back to study it. Like, I don't want you doing anything for my class over break. Nothing. But it's just going to be on the polyatomic ions.
What's that?
It's all it's going to be. So this is going to be it. Okay, a polyatomic ion is a chemical formula with a charge and a name. I do. And so this is all I'm going to ask. It's like on your quiz, there's going to be a left column and a right column. I'm either going to give you the chemical formula and the charge and ask you for the name, or I'll give you the name and you give me the chemical formula and the charge. It's going to be that simple. Absolutely. I'll give you a periodic table.
Is it going to be a blank?
Why are you so excited about this?
Because we're going to fail this miserably, and that's why he's smiling.
Whenever you guys get back, we're going to stress. This is why I'm so excited about it, Hannah, is because what we're going to do is you get the polyatomics. We get done with these Lewis structures. We really speed through bonds then and get through Vesper. We start on nomenclature.
He hates that. That's the
In
worst
January, we're going to be on nomenclature.
Why do you like it? Why do you like
Which means in February, we will be covering chemical reactions.
Stop saying that.
Which means at the end of February, in the beginning of March,
We do. Chemicals.
we will be on stoichiometry.
See? Yes.
See, now you're
Which means at the end of March and start of April,
I don't think I want to be a
we
doctor.
can go to acids and bases. We will cover everything that I've set to cover in this class. And at the very end, we may even get into gas laws.
Okay, I have a question. I know somebody's already asked this, but I need to write it down.
Okay?
So how do you get -2 and how do you get 8?
Okay, I got -2 because of the bonds.
Let's watch some Bill Nye.
Because
And the 8 is based off the octet rule.
okay.
We're going to keep going through these. It's not a yes, Hannah. Everything.
And so
Every bit.
How many questions?
That's the one sad thing I got. I've only got 45 minutes, so I gotta like hit and miss. That'll probably be the one thing that I give you that'll be a multiple choice. Yeah, there'll be a study guide and a practice sheet. It's called the ones I gave you throughout the whole year. I also am being nice enough for this. I'm keeping track
Of everything we've done.
for you guys the answer key for all the quizzes, and I will scan it and I will send it all out to you and remind so that you have these to review from as well.
what? For the end of the year test?
You do realize you just made it sound like we're going to have like 4 quizzes left before we get to trigonometry, whatever you call it.
Stoichiometry. Yeah, it's probably going to end up something like that. All right, so let's go here. We got this oxygen. How many electrons does oxygen want?
3. Oh wait, no, 8.
8. There we go. Wants 8. How many does this oxygen have?
That's 8. No, my bad, it's 2.
4.
Because
How'd I get 4?
because it's in
Because
between.
you have
2 bonds connected to it.
I'm still lost.
No, it's in the middle.
So 4 electrons,
Divided by 2.
and we do it by pairs, so we need 2 lone pairs.
Wait, how'd you get?
I'm a kid.
These don't make no sense.
Mama Jody would be crying.
So there's 2 twos. Does it matter where we put
Couldn't the dot, one electron?
On a technicality, no, because you haven't went over Vesper right now, but I like to spread it out as much as possible. Okay?
Mr. Hall.
Yep.
Couldn't one electron dot just represent, couldn't like the 4 dots just, can you just put 4 dots on it and say, hey, there was no 4 there, so there's 4 dots? Do you have to divide by 2?
You don't have to have 2. You just got to know it's lone pairs. Only 2s go together. If you put me 4 dots together here, I'm going to mark that wrong. All right, let's go with this oxygen, and it wants 8. How many does that oxygen on the end have?
2.
2. 8 minus 2.
That's 3.
6. 3 lone pairs.
No, no.
This isn't bad.
All right, from here, we've given everything a full octet. Number 3, calculate the number of electrons you must show. You use the periodic table for this. So look at the elements you got. So we have oxygen. We only have oxygen. How many oxygens do we have?
3.
How many valence electrons does oxygen have?
4.
8.
No, it's 4.
I can't see.
I can't see what it says.
Valence
6.
electrons.
That's 3.5.
Why is it 6?
Because it's in the 16th column.
It's in the 16th column.
That's how it's right.
16th column has 6 valence electrons. Oxygen has 6 valence electrons.
Sorry, but mine died there for me.
You're fine. For some reason, I feel like this weekend has been a break. For some weird way.
It's because basketball was through it all, and I was here all the time. Literally, I was here from 10 o'clock to 12 o'clock Saturday.
I love the white 6.
Because first column, 1 valence electron. Second column, 2 valence electrons. 13th column, 3 valence electrons. 14th, 4 valence electrons. 15th, 5 valence electrons. 16th, 6 valence electrons. 17th, 7 valence electrons. And 18th is 8.
So you skip pretty much 3 through 12.
Because they're freaky and weird, you don't worry about the details.
Okay.
Okay? Good there?
Sure, yeah.
Alright, so 6. So 3 times 6 is
18.
18. We are to only show 18 electrons, and we must show 18 electrons. Whatever you two are doing with it.
They're terrorizing me.
We're showing 16.
So,
PTSD.
step 4, we count the number of electrons we're showing.
We're showing 16.
1, 2, 3, 4, 5, 6, 7, 8. These bonds count as electrons, these count as 2. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm showing 20. I can only show 18. I'm showing 2 electrons too many. I'm going to go on and openly tell you, if you do a count with this and you are showing less than what you're supposed to, you have jacked up somewhere.
So, but it can be more.
Yes, because we're showing 20 right now and 18, so we have to fix it.
Why do you have to have 18?
Because each oxygen only has 6 valence electrons.
So
How'd you
every
get-
time it'll be 18? It'll have to be equal to 18?
No,
I have a question.
it depends on what's in it.
I've completely blanked out. How'd you get 20?
I just count.
Wait a second, how'd you get
1, 2.
20? Yeah, how'd you get 20?
Alright, follow with me here, okay? 1, 2, 3, 4, 5, 6. Everybody sees the lone pairs.
Yeah.
This is where everybody misses it. 7, 8. The bonds count as 2. They're still being
Why can't
shared.
we put something there to like give us a reminder of it? Why can't we put like dollars there?
Because you're going to in a moment. In step 6, you'll mess yourself up. Is everybody good there? Do I need to keep counting?
It makes sense now. Okay.
Okay. Alright, from here, this is where you go into step 5. Adding double and triple bonds where needed to fix the number of electrons you're showing.
I thought you could only have 8 total electrons.
Yeah, you're showing 20
That's what I'm saying. How are we gonna fix that?
by adding double and triple bonds.
Oh, okay.
Alright, in this case, we need to add a double bond. Where are we going to add it?
In the middle.
And these.
The left or right?
Oh, right. Left. So,
Alright.
does it matter
All right.
where you add it? Honestly.
No.
So we could have said right and you would put it under the
I'll
right.
put it on the right. But it's going to lead to something interesting here in a second. Okay, you chose left. So in this case, this is the thing. You've put a bond between these two oxygens now. If you count this up, you're breaking the octet rule. Will oxygen break the octet rule? No. There's only 4 that break it. Hydrogen, boron, phosphorus, and sulfur. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons here. So how do we fix it? Erase a lone pair.
Yeah.
Here's the thing I want to stress to you. You guys have got to get this. Look where you put the bond. The 2 atoms you put the bond between is the ones you need to focus on. You put the bond on this one also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What? So you gotta take out 2 again, too?
That's all you do.
I don't want to.
Take out 2.
So every like circle has to have 8, including the little dash.
Yeah.
But
They want the octet. Now, check it again. 1, 2, 3, 4, 5, 6, 7, 8. Is that oxygen good? Got an octet? 1, 2, 3, 4, 5, 6, 7, 8. This oxygen good? Alright.
yeah, but you just erase 2 that they can't just disappear. You have to do something with it.
No, you can just make them disappear. This structure exists. You're drawing it. These are the set of rules of how we get to draw it. Now count and make sure you're showing the proper number. We're supposed to show 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You are showing the proper number. Then there comes this interesting little tidbit in here. You all said put it on the left. What if I decide I don't want to be like y'all? What if Mr. Hall looked and said, I don't want to do what you guys did. I want to put it on the right.
You gotta take away 2.
Okay, so I take 2 away there. Am I good?
Then
No,
still
you
got
take
Why?
2 more.
2 in the middle.
Why I gotta take 2 out of the middle?
You can't.
Because then it's too much. But 1 oxygen in the middle.
What rule am I breaking if I leave it?
Octet rule.
Am I good now?
No.
Why?
Yes, you are.
Okay. Okay, question.
She said no. It's like
You all say here. I say here. Who's right?
Fun.
It doesn't matter.
It doesn't
matter
matter
because
because
they're
they're
bonded
both showing the same amount of work,
It's just
but they're just different sides.
You're right.
I won't say
Backwards.
I won't say we're right because I'm thinking of like the arrows. Like you start from the left and you go to the right. Yeah, that either or.
They're equal.
Yeah.
Yeah. They're equal.
They are equal.
Because they're all bonded together.
So in it, you have to put an equal sign with 2 arrows capping it between them. you must show me this and show me this also, because they are both the proper Lewis structure for this.
So when you give us problem, we gotta show both of them.
You have to show both because of a little thing we call resonance
Science.
structures.
Mr. Hall, this will be the number 6, right?
Not yet.
So what number? 5?
This still goes with 5. We'll fill it in. Resonance when applied. There we go. Resonance structures are Lewis structures of
Yeah.
the same molecule different shape / orientation. So the big thing with this is there is a subtle difference between these two. I know it doesn't look like it, but at the level you're at right now, this is the most simplistic way we can show these, and it absolutely matters. Okay, one day we'll come in here, I'm going to talk to you about these resonance structures and show you they actually truly really matter. If you don't keep an eye on them, it will end bad for you. Now we're going to go to the thing that is number 6.
Very good.
Properly check charge to make sure they match. What I'm talking about to making sure they match is the charge, overall charge of these have to match the overall charge of the molecule. Is there a charge shown right here for the molecule?
Yes.
It's not there now. Do I have something written?
No.
So is there a charge?
Yes, there's still a charge. It's just not good.
No, Mikey.
There's not. It's neutral. This is the key. They must be neutral. I'm going to show you physically what you need to do mentally. Okay? There's a key to this.
My mental brain's already gone from this.
This is how you're going to do this. This happens when you're checking charge. I can only stress this when you're checking the charge. You will split the bonds in half. And you will split the electrons back out to the atom. So one goes here, one goes there, one goes here, one goes there. Same thing here. Okay? When you do this, you're going to look at the charge. Whenever you're looking at the charge of that atom, you will take the number of valence electrons that it has off the periodic table and subtract the number of electrons that's being shown now. Charge-wise. In this case, how many valence electrons does oxygen normally have? 6. In this oxygen, how many valence electrons are we showing? 1, 2, 3, 4, 5, 6. So that's 0. This oxygen is neutral. But when you go here, in the middle, how many valence electrons normally? 6. Minus what's showing now? 5. Which equals positive 1. You must then show a positive charge. Then go here on this one again. 6 normally. Subtract out. 7 gives you negative 1. You get a negative charge. Check your charges and see if they cancel. And see, you're not cancel. You want to see if they match the charge of the molecule. A positive and a negative. They cancel out to give me neutral, and my molecule is neutral, so this is right. Make your life simple. This oxygen is the same as that oxygen. But this is the key. This is the thing I'm stressing. I'm recording this. This is the thing that I'm stressing to you. You cannot give me that as an answer. You must draw this.
about to. Where? Oh, never mind. That's my bad.
So you show the charges, you show the resonance structure, you show all possible resonance structures where they apply. That is the true final answer. That's what I'll be looking for. If the charges are not included, it is wrong. If you do not show the resonance, then you are wrong.
And that is ridiculous. See, Mr. Hall.
Later,